Welcome to your video on factoring, GCFs, and difference of squares. Let's begin with what is a factor. 3 and 5 equals 3 times 5 equals 15. 3 and 5 are the factors of 15. Factors are basically components of multiplication, two numbers or more than two numbers that multiply to create another number. So if somebody said factor 15, you would just rewrite it like that, written as something times something, the numbers that multiply to make 15. Likewise, in algebra, we can do the same thing. Right now we have an expression, 5 times x minus 4. If we multiply through, we get 5x minus 20. So, going backwards, if you began with that expression and somebody said factor it, you would think, how can I rewrite this so that it is a something times something? And if you look at the two parts of that expression, the 5x and the negative 20, both of them have a 5 as a common factor. So we can factor out the 5 and rewrite the expression like this. Now it is 5 times x minus 4, so we've written it as factors. That is essentially what is behind what is called factoring GCFs. A GCF is a greatest common factor. So here's another sample problem like that. We have an expression, 8x squared minus 24x. You look at that expression and you think, what is the greatest common factor of both parts? In other words, what is the greatest number that can go into this and go into that? Or in reverse, what is the greatest number that you can factor out of this and out of this? When I look at this, 8 goes into 8 and 8 also goes into 24. So 8 will be the number I pull out as my greatest common factor. But we also have x squared and x. From both of those, you can pull out an x. So I'm going to rewrite the expression like this. 8x times something, because 8 comes out of both and x comes out of both. Now what's left on the inside? X minus 3. Because if you pull an 8x out of this, you're left with an x here. That means 8x times x will bring you back to here. And if you pull 8x out of that, you're left with a negative 3, because 8x times negative 3 will bring you back to that. This is now factored form, because we have something times something. Now that you've seen that simple example, try these two. Think of the GCF, and then rewrite in factored form. Check your work. How did you do? This one here factors into this. The greatest common factor is 2x. 2x goes into both of those. There it is rewritten. In this one here, it's a little bit trickier perhaps, but if you noticed in red here, a plus 1 is common on both sides, or common to both parts here. And that means that was factored out, so that was pulled out here, and the remainder is the negative 4 and the a plus 2 over here, which simplifies to this. Now let's look at what's called a difference of squares. Here's an expression, a squared minus b squared. This is called a difference of squares because we have something squared minus something squared. Difference in mathematics means subtraction. So something squared minus something squared. Whenever you have an expression like that, it factors into this. A plus b, a minus b. Let's look at an example. X squared minus 16. This is something squared, this is also something squared, and they're being subtracted. So it's a difference of squares. So I'm going to rewrite it in this form. What is being squared here? X is being squared. And on this side, what's being squared here? It's a 4. 4 is being squared. So we have a difference of squares. So now that can be factored into x plus 4, x minus 4. So when you begin with a difference of squares, you'll always factor like that. One will have a plus sign, one will have a negative sign. Another example, 9x squared minus 36. When you look at this expression, the first thing you have to ask yourself is it a difference of squares? I think it is, because here we have 9x squared, which is actually 3x squared, and 36 is 6 squared. So I'll rewrite it like that. This first part is actually 3x squared, and this second part here is 6 squared. So we have a difference of squares. That means that factors into 3x plus 6 and 3x minus 6. This is now factored form because we have something times something. Those are factors. So that expression factors into this one. Now that you've seen those examples, try these two. Do you recognize the difference of squares, and can you factor them? Alright, check your work. How did you do? In the first one, it's 4, which is actually 2 squared, and 9y squared, which is actually 3y squared. So it factors into this. In the second one, again we have 9 and 16. However, there's an a and an a cubed. So first you look at that and we go back to our beginning, which was GCFs. Is there something common to both of these? Common to both of these is an a. That means an a can be factored out first. So a was taken from there and a was taken from there, and we're left with this. Now this is 3 squared, and this is 4a squared. So that is a difference of squares, which factors into this. Alright, now that you've seen those examples, if you didn't take notes and you found that maybe difficult or challenging in any way, you should go back, take notes from the presentation, and then you're ready for the practice assignment, which you can find on the website. You can do it.